The James Webb Space Telescope, or JWST, has a set of 18 gold-coated mirrors that are 21 feet long and 4 inches thick. This causes light to bounce back into an infrared sensor. Its ultra-wide viewpoint allows it to see around a third of the sky at once. It's approximately 3 times the size of the Hubble Space Telescope, which first launched in 1990 and has produced some of the most stunning photos of space. NASA plans to use the new telescope to learn more about the universe's beginnings. It could also reveal information about distant exoplanets that could harbor life. It should also aid academics in their understanding of Sagittarius A. Scientists have yet to photograph what they believe to be a supermassive black hole at the galaxy's core. On December 25, 2021, an Ariane 5 rocket launched from Europe's spaceport in French Guiana to launch the telescope. It took about a month for it to arrive at its final destination, the L2 Lagrange point orbiting the Sun, which is just beyond Earth. The gravitational forces between the two are stable at this moment. It allows the telescope to be pointed away from the Sun for the duration of its operation, which protects the instruments. The telescope will also avoid being shaded by both the Earth and the Moon due to its position. Meanwhile, the Hubble Space Telescope rotates in and out every 90 minutes. In around 5 months, operations are likely to commence. JWST is planned to be operational for about 5 years. JWST has completed its alignment and is now focused. NASA and the European Space Agency, or ESA, have reported that all of the Space Observatory's imaging instruments passed the 7th and final round of testing with flying colors. Webb is the most ambitious and complicated space scientific telescope ever built, with a large 6.5-meter primary mirror capable of detecting faint light from distant stars and galaxies. Its main purpose is to detect infrared light emitted by distant stars, planets, and gas and dust clouds. It is around 1 million miles away from Earth, yet it'll glimpse light from the first stars and galaxies. The first photographs, a series of 10 released to the public, show the observatory's entire field of vision while pointing at the Large Magellanic Cloud, or LMC, a small satellite galaxy of the Milky Way seen from the southern hemisphere. The sizes and positions of the photos indicate the relative arrangement of each of Webb's instruments in the focal plane of the telescope, each aiming at a somewhat offset portion of the sky relative to one another. JWST is equipped with 4 scientific instruments, including the NIRCam, or near-infrared camera, which detects light from the very first stars and galaxies. It has a coronagraph, which allows it to block the light of a star, which aids in the search for planets orbiting neighboring stars. IRIS, or near-infrared imager and slitless spectrograph, for detecting first-light stars and exoplanets as they cross their star. NIRSpec, or near-infrared spectrograph, a spectrometer that converts light from an object into a spectrum. This instrument can observe 100 times at the same time. MIRI, or mid-infrared instrument, a camera and spectrograph that detects light in the electromagnetic spectrum's mid-infrared region. Although NIRCam and NIRSpec will do much of the cutting-edge science, it's the MIRI camera that'll most likely provide us with better than Hubble wide-field astrophotography images. The image from MIRI sticks out in this first group of images. If you look closely, you can observe emissions from both interstellar clouds and starlight. Calibration photos from the observatory's fine guidance sensor were also given as a bonus. It uses 2 sensors to accurately and precisely orient the observatory. Therefore, it isn't there to undertake scientific imaging. These remarkable test images from a successfully aligned telescope demonstrate what people across countries and continents can achieve when there is a bold scientific vision to explore the universe, said Lee Feinberg, Webb Optical Telescope Element Manager at NASA's Goddard Space Flight Center. These images have profoundly changed the way I see the universe, stated Scott Acton, Webb wavefront sensing and control scientist, Ball Aerospace. We're surrounded by a symphony of creation. There are galaxies everywhere. It's my hope that everyone in the world can see them. NASA also produced a short film to go along with the images. Webb's initial 10-year mission will study the solar system, directly image exoplanets, photograph the earliest galaxies, and investigate the mysteries of the universe's origins. And that's all for today's video. Thanks for watching. If you enjoyed this video, then do like, share, and subscribe to our channel for more such exciting content. See you in the next one.